In the last video, I actually made a mistake. I wonder if anybody has spotted it. If you look at the z parameter, the z coordinate of the starting point of the window should be calculated from the center of that wall. So this should be the half height of that wall. So instead of 4, it actually should be 3. So what was the result of this mistake? If you look at the simulation results, let's open the file again. So the starting point was set too high, hence for a taller window like in this one, where the height is 2.5 meters, the window should extend beyond the wall. So let's look at this case. It's 002. So let me find the output folder again, and let's see 002. And we can look at the geometry. And as you see, indeed, the window is actually sitting beyond the wall. So if you look at the error report from jEPlus, it only gives you a warning, like here, saying that the window doesn't fit within that wall. And the simulation continues as usual, with no severe errors. The question is, does this error impact on the simulation results? We can't easily see from this result table. So let's do a little experiment. What I will do is to change the reference point of the z coordinate and run a few cases and see whether or not the simulation results will be significantly changed. The way I'm going to do it is to insert another parameter before z. Instead of using the fixed numbers, I'll reference that parameter. Unfortunately, in jEPlus, you can't within the list. You can only append to that list. So what I'm going to do is to duplicate current parameter and then change the original one. So I made a copy of this first. You see we have the 11th parameter. It's also called P10. I will change it to P11. And the rest will remain the same. But I will change this one to, I'll call it Z center. And that's the center point reference for Z. And the search tag, it doesn't make any difference, but it shouldn't be Z, so I just make it a little different. And for the values, I want to test, say 1.5 is the number we should use, and about 2.5, maybe 4. Sorry, maybe 4. So 3 different values. If it is 4, then we can guarantee that window is completely outside the base wall. Right, and then next thing I need to do is to, in the z parameter, reference z center. So instead of that, I want to do P10. Okay. Now, if you look at the preview window, this is actually wrong, right? It's actually referencing the heating set point parameter, which is P1. So this is one of the, let's say, limitations in jEPlus. It's the way it interprets this formula is a little dumb. It will find the match of P1 first and then just settle with that. Rectify this issue, there are several ways. One way is to change all your parameter using a more consistent naming convention like P01 and P02, etc. So you can avoid such duplications. So this is one way. Of course, you can also, if you don't want to change your previous parameters, you can also change P10 and give it a special name. So rather than P10, you can you can do p_10 and then reference that to avoid confusion. See, now this time it's correct as well. So it's not ideal, that's for sure, but this is what jEPlus does. So you need to be careful about this and check the preview window every time you make some changes and see if jEPlus understands your intention correctly. Right. I think I'll make it a little more consistent. I'll call this PA and I'll call this PB. So you can imagine this look a little better. Doesn't make much difference, but let's do it that way. So I have another parameter in there, and if you validate the project, you get even more cases. But all we want to do is to test if the center point is as such, and if the window is large enough, and some of them will be completely outside the wall, what impact will it be on the simulation results? So we don't need that many combinations. We actually just need to run 3 cases out of the whole set. The way to do it in jEPlus is to fix the parameter values in other parameters that you don't want to change. So for example, for heating set point, we set it to the top end, so 23 degree as the heating set point by choosing the last element in that list. And so is cooling, but this is less important in our case. We give it a fairly high infiltration, let's say 10. You have to count which one is the 10th value, but it doesn't really matter much in our case. So for insulation, put 1, wall construction 1, overhang 1, width. Let's make it wide enough, so 2 meters wide. For height, we want maybe not the biggest, relatively large window, and the rest is only calculations, and the reference to the center point, we keep it as a parameter. Now if you validate that project, still got 24, so there's something I forgot to change. Of course, there's one before that, which is the orientation. Now I turned the room around to the 4th value, which is a 135. So the window is now facing northwest. And now if you validate it, there's only 3 jobs left. And once we finish this change, and we can run the whole project, which will contain only the 3 different center reference points with all other parameter values fixed. So let's go to execution, and last time we ran it with a random sample. Now this time we can run all the cases in the project, which is only 3. So let's run it. Okay, and let's look at the results again. I think I might have forgotten to close the Excel file, and that's... I have to run it again. It will be rather frustrating if that happened when you run some long simulations. But the good thing is, if that happens, all you need to do is to recollect simulation results. So you can uncheck those and run the exact same project again just to collect the results to get that file populated. Right. So now let's look at the results. This time it contains only 3 cases, and we see that center point is have 3 values, so the rest are fixed. And if you look at the simulation output, there's some minor impact, but certainly not anything like the wall doesn't have a window. Okay, and that for sure some of them you will see very strange things. We can go out to the output folder. And there's something else to mention. The last time we ran a random sample, the naming convention has changed to LHS-a serial number. This is what you get when you run a random sample using Latin hypercube sampling method. The simulations we just run is the whole project, and the naming convention becomes G followed by a serial number. This happens when you have more than 6 parameters defined. Now we have 11. No, we have 12 because it starts from 0. So we have 12 parameters. So when you run a full set, jEPlus will name the cases using a serial number, because otherwise the folder name will become very long and exceeding the length limit of your operating system. So this strategy is for preventing that from happening. The way to find your case is always go to the summary table, and you can look at job ID, and this will be your folder name. Let's go back there. And we know this one is the one with the center point most furthest off. And if you look at the geometry, and indeed the window is completely out of the wall. The simulation result, although there are some differences, it certainly doesn't seem to be a lot, isn't it? Why jEPlus does this, I'm not going to get into today, but it involves some important concept about thermal zoning and how the heat transfer surfaces are treated in jEPlus. So it may be worthwhile to read the documentations to figure out why.